Hello everyone, this is a video lecture for College Algebra, Math 1414, Section 2.2, more. We're going to do more math. These are just a lot more things from 2.1, now we're doing 2.2. There's not one really big concept. We're going to just do a lot of stuff, so here we go. Anyways, the first question we're going to do is about increasing, decreasing constant. And they have a parabola, and this is about -2 right here, where that minimum is. And they're saying find the intervals of increasing, decreasing, and then constant. What does that mean? So as we're reading left to right, read left to right, just like we normally read left to right. As we're going in that direction, we're wondering, is the graph going down or up or flat? So are we going up, we're going down, or we're flat? So as I'm going this way, notice that the graph is actually going down. Yeah, there's this arrow right here. That's deceiving. We don't want that. We're going this way, we're traveling this way on the x-axis, and you can see we're going down here, okay? And then at -2 is when it's like it just stops for a second, and then it goes up. So over here we're decreasing, and on this side we're increasing. I want to put that into interval notation. I want to say, where is it decreasing and increasing? So -2 is kind of the hot number. Again, I'm looking at the x values here. It's kind of like a domain, kind of. And I'm going to go from -2 and onward. I want to say going from -2 onward. Here's the thing, though. I don't care about going up, however up I'm going. I know I'm going up. I'm increasing. I want to say I'm going this way to positive infinity for x. -2 to positive infinity. These are x values. It's kind of like a domain. On the other side of things, I'm decreasing here. Now, I know that, again, I've started really high, and then I'm going over to -2. I don't really care how high it is. I'm not asking about y values. I'm saying, where did we come from? We came all the way over here from negative infinity until the -2. Negative infinity to the -2. Okay, so again, we're reading this left to right business. We're starting here at negative infinity. -2 is where something changed, and we keep going to positive infinity. It's like a number line. Where is it ever constant? You might be thinking, oh, right at -2. Not really. Constant is when it's flat for a while. There's nothing really going on here, so, well, none. So there you go. One other thing to note is that, see how I'm using parentheses right here on the -2? You're going to always use parentheses when dealing with increasing, decreasing constant. Reason why is because here, right at -2, right here, am I increasing? Am I decreasing? Am I constant? Right here, this dot, just a dot. Here, let me just, a dot right there. Is that dot increasing? Is that dot, is it decreasing? Is it even flat? You can't even tell. Nobody can tell what a dot does because a dot doesn't mean anything. So at that dot, we don't really know. There's nothing really to talk about. But after the dot, but before the dot. Okay. Let's do another one. If that's kind of weird, just focus on the x values. That's the biggest thing out of all this. Don't put y values. In fact, that's why a lot of people get this particular question wrong. They'll go and say, oh, well, it's a height of 2, so I'm going from 2 down to negative infinity or something like that. No. None of that's true. Don't even think like that. I'll leave the 2. I'll leave the 2 there just so that you can see I'm not going to use it. They want to know, when is this graph increasing, decreasing, and constant? Here we're going to actually have something constant, if you can tell. Reading left to right, this way here, you can see that I have it flat for a little bit, so that's constant right there. And then we're going down. So this is decreasing here, decreasing. Are we ever increasing? Nope. So I'm constant and then down. Let's do the math for it. So decreasing, I'm going from negative... Oh, sorry. I was thinking of a constant thing here. Decreasing is actually from right here, the -3, and I'm going to go down, down, down. So -3. But you're thinking down, down, down to negative infinity down here, right? No, 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 no. That's a y value again. Where are we going x value-wise? Positive infinity. What about constant? Well, constant, again, I'm saying I'm traveling constantly until negative 3. I'm going from way over here, negative infinity, up until the negative 3. I see these infinities here as like the left side of the page and the right side of the page. Right here, on the left side of the page, did I come from the left side of the page? Here, would this line eventually touch the right side of the page? Use the infinities. Again, we're always thinking x values. All right. 2, 2, 9. This is something new. I have a W shape. Looks kind of like this. And I have a W shape. It's already got 2 there. We got a 3. We got a 4. And I guess right here this is at negative 1. And they're wanting to know where are the... Oh, I guess there's 2 different things actually on this one. Where is it increasing? Where is it decreasing? There's no constant, so I don't really care about that. Where is it increasing and decreasing? This is part A, let's say. I think that what I've done is that I took this problem and I've done kind of 2 problems with it. So I don't think, like if you go to 229 on the homework, I think it's going to be not as much as what I'm going to do. I can't really remember. I think I'm combining 2 problems together here. Anyways, so where is it increasing, decreasing, constant? Notice that, again, reading left to right and ignoring these arrows, because they're very deceiving, I'm going to go up, so I'm increasing. And I'm going up right here as well, increasing. Yeah. But right here, I'm going down, I'm decreasing. And here I'm going down, I'm decreasing. Okay? So I'm increasing from the left side of the page, from negative infinity, not because it's down here. I don't care about y values. I just know that it's going up. But I'm starting over here, left side of the page, negative infinity, going all the way until 2. And then because there's another one, I would say comma or union. I have a comma here on mine. Apparently I had used the union, and that was no good. I have even written right here, comma separated. So they want commas in this particular case, not unions. And then I'm going right here from 3 to 4. And that's it. That's your answer for that one. Decreasing, use the red again. Notice that I'm going from 2 to 3. From 2 to 3. And then from 4 onwards. Now, I know that we're going down. Again, though, I don't care. I'm going to say I'm going to the right side of the page. I'm going to a positive infinity. And there you go. All right. So I'm going to say part B, though. Again, this might be the same problem or not, or whatever. They're wanting to know where's the minimum at x equals something. And then the minimum value is y equals something. My math lab does not make it this clear. It does not make it this clear. I'm going to make it this clear, but they don't make it this clear. What's a minimum? It's the lowest part of a valley right here. It's this guy. I guess you could say it's a relative minimum. I know that it goes down forever and ever here, but I'm just looking for valleys and hilltops and stuff like that. So where would the water pool, you know, that kind of thing. Right here. So that what's the x value of that point right here? 3. What's the y value? Negative 1. This is what you're going to be doing in my math lab. You're going to type 3, enter. You're going to type negative 1, enter. And that's okay. That's it. They're going to have a lot of words. They're going to say yada, 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 and it's very confusing in my opinion. But this is just what you're doing, just the numbers. So maximum at x equals something. And then maximum value is y equals something. This one's a little different because maximums, I'm trying to use a different color here, maximums are going to be the tops of the hills here. And so I have it at 2 and 4. So you're going to put a 2 comma 4 here. What's the y value for both of them is 0. Now apparently you could also put 0 comma 0 and it would still work. That's what I have on my notes here. But it's silly. Just put a 0. Again, what's the y value there? 0. Okay. Got through that. Now let's get on to something fun. So 2.2.17. Let's talk about even, odd, neither. Even, odd, neither. And they're going to present on this particular problem y equals x squared plus 3. And so they're going to say, is this even, odd, or neither? Can you take a guess? It's even. Wow, how did you know? Okay, so let's talk about it. We're going to basically look at the powers. That's what I have here. I'm going to say look at the powers. When I'm looking at the powers here, I have a 2 power. And technically here, this is x to the 0. And 0 is even. So we got an even. We got an even. So guess what? It's an even. That was easy. Well, what about that 3 right there? You got a 3. That's not even. I don't care about the 3. I said look at the powers. Okay. Now there's a formula for making all this stuff work. For even, it's f of negative x is equal to f of x. And for odd, which we haven't talked about yet, is f of negative x is equal to negative f of x. Y'all confused yet? So it's okay to use these. I mean, it's fine, whatever. But I would rather look at the powers because that's what makes sense here in polynomial land. They're going to ask for a part B to this, and they give you some other options. They say, is this y-axis symmetry? Is this origin symmetry? Or, again, neither. So now we got to click which one of these. Because you said even, it's always y-axis. If you had said odd, you would say origin. Odd, origin. Odd, origin. And then neither, neither, obviously. So even, y-axis. Odd, origin. Neither, neither. Always. I think this doesn't really help by just giving you words. So I'll rather show you graphs of what this means. Now, cool, it's cool to look at the powers and we're done. But what does it mean to be the symmetry and all that kind of stuff? What's the point of this? So even symmetry kind of looks like this here. It's not perfect, but I'm going to choose x squared as my graph. And notice that I have this symmetry about the y-axis. Basically, whatever's on this side right here is the same as this side right here. You see they're the same on both sides. Kind of like someone's face. You know, your own face. You go to the mirror, you look, you got the two sides of your face are the same. So, even. And notice I chose x squared in particular because, well, guess what? That's a even power. It's all making sense now. Okay, what if I did x cubed? X cubed. So, in this particular case, I have, it says origin symmetry. I'm going to show you that. Origin symmetry. And origin is just that center dot in the middle. So how is it symmetric about this dot? That's not isn't that kind of weird? What if I were to rewrite this side right here? Tick, 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 kind of like a clock. Tick, tick. And if it keeps ticking, tick, 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 eventually you would get the exact same as the other side. It's kind of like clock hands. If you make the minute hand go around, wouldn't it eventually hit the hour hand, right? That's the idea. So again, this is odd. And you can see that because it's an odd power. So now you can see the difference. So this is y-axis, and this is origin. This is even. This is odd. And if it doesn't fit either one of those, then it's neither. So now you know what's going on with the symmetry stuff. But when it comes down to the math, we're just simply looking at the power. So let's do another one here. So f of x is equal to x to the fifth minus 6x. And they're saying, is this even, odd, or neither? And so looking around, I see a 5 power. But what's this power right here? 1. It's a 1 power. So I got an odd number here. I got an odd number here. Both odd. We'll go with odd. And because it's odd, part B, what are you going to pick? You're going to pick origin. Odd origin. Odd origin. Neither, neither. Okay. And then lastly, 2 to 39. I've got f of x is equal to x to the 6th minus 4x. They say even, odd, or neither. Which one? Notice here I got a 6 power, and then here I got a 1 power. I got an even and an odd. Can't be both, so therefore, neither. Cool. And you would then click neither again, because that's your part B. Okay. Cool. And you'll never see that topic again. No, I'm just joking. It's important. It's just a lot of these, hey, look at this. Hey, look at this. So 2.2 is a whole lot of, hey, look at this. So, hey, look at this. Now we're going to talk about piecewise. Didn't spell it right. Piecewise. Piecewise functions. So near and dear to my heart. So in this particular problem, we got 2x plus 3, and then we got 4x plus 7, and x less than 0 over here, x greater than or equal to 0. Cool. What they're wanting in this particular problem is to find f of negative 4. Okay, f of negative 4. Well, what we need to do is find out which one of these it matches up to first, and then we plug it back into the one that makes sense. So I'm going to look right here. I'm going to say, okay, is negative 4 less than 0? And that's a true statement. So I'm going to be using this one in order to find what the y value is going to be. But let's just test the other one since we're here. Is negative 4 greater than or equal to 0? No. So don't use that one. So I'm going to use this one to find out the value. I got 2 times negative 4 plus 3. Negative 8 plus 3 is negative 5. Now, I drew all over it, unfortunately, because the next problem is a little different. Part B says find f of 0. So I'm going to go through and check to see which one it makes sense with. Is 0 less than 0? No. Is 0 greater than or equal to 0? Yes. Little equal sign down there. So I like this guy now. 4 times 0 plus 7. Notice I'm just plugging it into that function. Instead of x, you put a 0. 4 times 0 is 0, plus 7 is 7. There you go. Last one. F of 4. Is 4 less than 0? No. Is 4 greater than or equal to 0? Yes. So use this guy again. 4 times 4 plus the 7. 16 plus 7 is, it says 23 in my notes, so there you go. Okay. Cool. 263. So I've got f of x is equal to x plus 1 and x minus 1. And they give me constraints saying that x is less than negative 4, and then I got x is greater than or equal to negative 4. Okay. I like to think of this, again, I'll show the rest of it here. I like to think of this as on the left side because it's less than, and I want to see this as at the right side because it's greater than. Left side less than. I shouldn't have done anything there. And right side greater than. Okay. They want a graph of this. Okay. Now, could I just go to my graphing calculator or Desmos or something like that? Yes, but I'm trying to prepare you for exams where this will come up, the first 2 exams. They're not wanting you to use calculator, so I want to go and do this by hand if I can. Now, the funny thing about this particular problem is that you're going to learn how to graph this in the next section. Right now, they're just saying multiple choice, figure it out. And it's not too bad. So one thing to start with is negative 4 is kind of like the boundary line. So negative 4 is, I don't know, like the border between 2 different countries. We got the left country and we got the right country, okay? And negative 4 is what is keeping them separated, okay? I want to graph this function on the left side. But in order to do that, I really just want to graph this at all. One thing to note is that the slope, again, this is way ahead of us, the slope is a 1, and I have a y-intercept of 1. Now, if this doesn't make entirely a lot of sense when I'm saying slope and y-intercept, I don't know, maybe you're thinking mx plus b, y equals mx plus b. If you're not thinking this, just kind of follow through with me for right now. 2.3 is all devoted to this, okay? We will see it again, but let's just say you do know, and I'm assuming right now you're just going to hang with me on this here. I want to graph this. I'm going to start here at 1, positive 1, and then I have a slope of 1, which means it's 45 degrees, basically. 1 over 1, there's my next point, and there's my line for this graph. Something kind of like that. The thing is that this line belongs right here on the left side. This is a left side graph. What is it doing over here? And so the right side country is really upset that this left side country let its line get all over the place and make a mess. So it's going to go clean it up. Just like I'm doing. I don't have a big eraser on this, I'm sorry. That's the point. I'm trying to erase it. I know where it was. I know how I got it. I just want to get it out the way because that wasn't part of my graph. Okay. Guess I can erase those little guys too. Let's do blue. Okay. Oh, there it came back. So, same thing here, a slope of 1, but now I'm starting at -1, and I want to be on the right side. Regardless of left or right side, I definitely need to draw it just to see what it even looks like. So, -1, and I got a 1 over 1 slope is 45 degrees, and so it looks something kind of like this, I'm thinking. That's my line. I don't care what side it's on. I just want to draw the line. Oh, but wait, it's supposed to be only on the right side. These left side people are very upset, and they're going to erase any kind of arrow over there. It shouldn't be on the left side. I don't know what they were thinking. Making a mess on my side of the territory. Ugh. Those right side people. So rude. Joking aside, so one last thing, because we're almost there. You've graphed it. This looks great. Notice that this does not have an equal sign, but this one does. This has an equal sign. Equal sign means we're going to have a solid dot there, like solid square brace kind of stuff. While this one does not have it, this will be an open circle. An open circle, so that, or parentheses kind of thing. So we'll have a circle there, and we'll have a solid there. A solid on the right side, so connected to the right line, but a circle on the left side. So a circle connected to this guy right there. And that's it. There we go. Again, if it didn't make a terrible amount of sense with the slope and y-intercept, that's the next section. We'll talk about that when we get there. Oh, one last thing. They're going to ask for what's the range of this graph. Looking at this graph, what's the range? It's actually negative infinity to positive infinity. That's your answer. Now, it doesn't make a... It's kind of weird because you're thinking, well, how does that work? I'm going to ask about possible y values. Is there a graph somewhere down here? And actually there is. Let me just go ahead and extend it for you. See? It goes on forever and ever. So is there a graph right here? Yes. Is there a graph right here? Yes. Is there a graph right here? Yes. Is there a graph right there? Yes. Is there a graph right there? Yes. Is there a graph right here? Yes. Is there a graph right up there? Yes. Okay, cool. Is there a graph everywhere? Yes. Everywhere. There's always a graph. And notice again, this is a range. That's the y values. That's why I was checking every y value possible. And we're moving on to the next topic. And you'll never see it again. No. Just joking. 2,273. Now we're going to talk about the difference quotient. The difference quotient. So they say f of x is equal to negative 4x plus 8. And they say, what's the difference quotient? And they just give you a box. You ever go and get some of these wrong 3 times? Like, here's the thing, and I if I haven't said it, I'm going to say it now. Sometimes it's beneficial to go into a problem and get it wrong 3 times on the homework. That way you can see what format they want your answer in. What are you even asking for? How am I supposed to make this, I don't know, comma-separated thing work? What do you mean by exact answers using radicals? Sometimes math lab might be confusing, and it's okay to get it wrong 3 times, submit, see what the answer is, and you can go from there. I'm going to do that right here with you, just because difference quotient. Let's give you a formula. They say f of x plus h minus f of x all divided by h. There you go. All right, do it. Here, I'll just wait. You can pause the video if you want. I don't care. That's a joke. The point is, I don't know what's going on, huh? And so let's get it wrong 3 times and just see what their answer is. And they say it's -4. I didn't just say that, did I? So, yeah, this is being recorded. Let's say I got 2x plus 3 on the next problem. You know, similar question. Let's see what happens. I submit it 3 times and I get it wrong. What do I get? I got a 2. Interesting. Can you imagine exactly what the next and the next and the next is going to be here? Yes. Do you have to do this difference quotient? No. But you would be missing out. You would be missing out not just on this homework, not just on the quizzes, not just on the exams. Yep, this is on the exam and not this one. No, you're going to get a harder one. But I'm making a point. You'll also be missing out in pre-calculus and especially calculus 1. This is a calculus concept. Here, I'll even put that right here. Calculus concept. Okay? Now, it's a more advanced concept in calculus. In fact, well, you would probably learn it within the first 2 weeks, but the idea, though, is I want to prepare you now so you can understand what's going on when you get to calculus. You are going to take calculus, right? You are here in Math 1414. So let's do the real math. Let's actually figure this thing out, and we'll talk about it, okay? So I want to do this difference quotient. Let's just do it with the 2 and the 3. Makes it kind of easy. So I want to do this big old formula here. What is that even supposed to look like? Well, I have an f of x, and then they're saying f of x plus h. Notice that we're just going to plug this thing in, and then we're dividing it all by h. So what I normally do when I do this is I say, I have f of x. I'm doing this problem here. What about f of x plus h? I just want to know, what would this look like? Just this little entity. Well, and it's not 2x, it's 2x plus h. And then I distribute the 2 to, make it a little bit nicer. And so I have these 2 entities. I have this guy, I have this guy, and I'm supposed to subtract them and divide by h. So here we go. This first entity, 2x plus 2h plus 3, subtracted by this guy. I'm going to put parentheses just because I'm that kind of guy. You kind of need parentheses over there. And then divide everything by h. You don't need parentheses for the first thing, but you would need to distribute your negative sign for the second one. Notice some things. If I'm combining like terms, these guys right here, they cancel. Here, combine like terms with numbers. What do you get? Cancel. So we're left with 2h divided by h. They cancel, leaving the 2. Leaving the 2. Do I have to do that every time? Couldn't I just look at the number right here? Actually, you can. But why? I'm asking you, why is it okay just to look at this number right here? Not to cheat. What's the concept? What's the calculus concept here? The calculus concept is this difference quotient is actually a slope. It's a slope. Now, we talked about slope very briefly back over here, if you remember. We had a little slope here. But I want to talk about, and the next section is literally all about slope. But I'm kind of half assuming right now that you know just a tiny bit about slope. And if you don't really know what I'm talking about slope, go to 2.3, because I'm just about to do that recording. Go to 2.3, go through the whole entire lecture, and then come back to this section and just kind of, rethink about it. They're looking for, here's my original question again. I got 2x plus 3, and they say, what's the slope? That's what they're asking. They don't say slope, they say difference quotient. But it's the slope. What's the slope? It's a 2. mx plus b. This is not hard. Not hard at all. But that's why. That's why you're doing it. Okay, one last one like this. I got, let's say I got -7x plus 1. They say, what's the difference quotient? which you already know. What's the slope? And you're going to say -7. And that's it. You're done. You don't have to do the long process every time. Okay. But now, what if they give you, I know they're going to give you this. This is on your homework. 227, f of x is equal to x squared minus the 5x plus 9. And they say, what's the difference quotient? Okay, let's think about this for a second. They want to know what is the slope of this quadratic. What is the slope of this quadratic? Do you know what a quadratic is? It's a parabola. I have a parabola. I'm going to say, what's the slope? And if you know anything about slope, the slope's changing constantly. The slope is always changing. There's all these different slopes going on. Okay, so that's not going to be helpful. I can't just give you a number. I can't just say -5. Because the answer is not just -5. But it includes -5. If you're noticing, I do have an mx plus b format here. And your answer will include a -5. I agree with that. But there's more to it. This right here, what do you do with that? What's the slope there? And that's my point. We need to do it the long way to see what that will yield. Okay? So, now I'm going to do it the long way. We have my original, x squared minus the 5x plus 9. And then I got x plus h is going to be x plus h squared minus 5 times x plus h plus the 9. And so now what I need to do is simplify this down. I need to actually, I don't know, get like distribute and, FOIL, factor, whatever I need to do here. So, first off, let's just rewrite this as a square, meaning there's two of them. Distribute the -5, so -5x minus 5h, and then plus the 9. Notice here I need to FOIL this one out. And so then I've got x squared plus 2xh, yeah, I skipped a little bit, and then plus h squared. I skipped that a little bit. I just kind of made it faster. So that's good. There's nothing else. There's no combined like terms or nothing I can see. That's it. But that's big. And that's only one entity. This is one entity that we'll be using. This is the other one. And we're going to subtract these two and then divide by h. So here we go. Get some room. X squared plus 2xh plus h squared minus 5x minus 5h plus the 9. All this minus, and then I got the x squared minus 5x plus the 9. Then all of this divided by h. Are you excited for calculus yet? No. When I distribute this into each one of these, they're going to change a sign. And what happens... Uh-oh. I don't know what that line is. Can I move the line? I'm going to leave the line where it is. I don't know what's going on. When I move that in, all these change a sign. Notice that this is a positive. Now it'll be a negative. This is a negative. That would be a positive. That's a positive. This would be a negative. You should cancel all of these out. You should be able to. If you're not doing that, you did something wrong along the way. Okay? Cool. So what do we got now? Left over, I got 2xh plus h squared minus 5h, all divided by h. Everything's got an h. Makes me wonder, couldn't I just cancel a single h in every place? The answer is yes. So I got 2x plus h minus 5. That's your answer. But let's analyze this. Let's go back to my original and understand some stuff. I got the x squared minus the 5x plus the 9, right? That was it. Oh, yeah, okay. Remember how I had said right here that you're definitely going to get a slope of the -5. See? That's your answer. But this guy right here was what was confusing. I didn't really know what was going to happen here. But now you do. But now you do see it. The calculus concept, because I have to show it. I talked about it. I'm going to have to show it. The calculus concept is this is a derivative. A derivative. Maybe you've heard of it. I don't know. Derivatives yield slopes. That's what we're looking for. We're looking for a slope. So if I take the derivative, I'll get the slope. And so derivatives, how this works is that 2 comes down to the front of the x, leaving you with a 2x. Do you see it? Over here on this side, it's always going to be the slope. I guess from this mx plus b side, again, you're just looking for slope, which we have. How'd the h come in there? Well, that's part of the algebra. In calculus, you wouldn't have the h. You would just have the 2x minus 5, and you're done. That's what the derivative would be. But the h is included, and you might be thinking, well, can I just do that next time and just put a plus h? Maybe. Maybe. Is it okay if I do another one? I'm spending a lot of time on this concept. On purpose, though. We got 2, 2, 77. In fact, no. Did I just do 77? Hold on. I was pretty sure that I just did this very problem. Oh, yeah. Oh, okay. I have it on 2 different pages. Okay. Yeah, that's fine. I want to do not 77. I want to do something else, if that's okay. So, hold on. I'm trying to get my pages back in order. Here we go, 77. Let's not say 77. Let's say 77B. There you go. I want to do one more for you, and it might not be on the homework anymore. What if we had a 3x squared plus 4x plus 5? Now, if you were just going to, see what the answer is by just kind of looking at it, hey, what's the slope? You can get some parts of it, I'm sure. I mean, there's a 4 in there. That 2 is going to come to the front. What happens? Is it going to be 6? Maybe. What about the h? That's kind of my question here. So let me do one more the long way, and then we'll look back at what we're doing. I'm going to say f of x plus h. And so then I got 3x plus h all squared, 4 times the x plus h. Oops. And I'm sorry for my sloppy handwriting. I'm just, at this point, showing you what it would look like. I guess if you don't want to keep watching this, you can just skip ahead. I don't know. There are other problems I'm going to do in this section. I just really want to make sure you're okay with this particular one because it's a longer one. It's an important one because you'll be doing this in calculus. Just maybe not with this amount of rigor, honestly, because by the time you get there to calculus land, it'll be much quicker. It'll be much quicker. That's just my opinion, though. Maybe it's just because you know math more, I guess, or maybe they just make it easier. Probably both. So I'm going to plug both of those in. This is a very long one. 3x squared plus 6xh plus 3h squared plus 4x plus 4h plus 5, and then all minus, all this stuff here minus my original 3x squared plus 4x plus 5, then all divided by h. I'm guessing you're almost probably just watching me. When you distribute this, you're going to get a negative in each one of these, so cancel, 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 and so then we're left with a lot of h's, so 6xh plus 3h squared plus 4h, all divided by h. Everything has an h, so you can cancel, cancel, cancel one of them, cancel. And so I got 6x plus 3h plus 4, and that is your final answer for this problem. Going back, I knew there'd be a plus 4, so that was easy. So that was an easy part right there. And if that 2 comes down to the front, 2 times 3x makes a 6x. So I thought that would probably work. And again, those are the important parts for your calculus concept, your derivative. Here in my math lab, they want that 3h. It's part of it. And so there you go. That's why we're doing it the long way, so that we can see what that middle term should be. It's not always just h. So keep moving. And this is the same question, but it's much easier. And we got f of x is equal to 7. And it says, what's the difference quotient? On my notes, I didn't even ask for difference quotient. I just said, what is the slope? Because that's what it is. I'm looking for the slope. What's the slope of this? Remember, mx plus b. I'm looking for that m right there. So what's the slope? There's no x. It's 0x plus 7. That's what it is. So my slope is a 0. 0. That's your answer. Last question. 22128. This is kind of like a word problem. Actually, it's not a word problem, but it has words, I think. Absolute value of x minus 10 minus absolute value of x plus 10. And they say go ahead and graph this thing. This is very simple to graph if you were to use, say, Desmos or a calculator. I have on my notes, make a table or use a calculator. I can't remember if I would have this, if this is on like one of the exams or not. I don't make these exams, I just kind of look at them. So it might be on an exam, so I definitely want to think like we're doing this without graphing calculators and stuff like that. If that's the case, then I'm going to be making a table. Okay, I know there's some kind of concept to making it work, but have you ever made a table? Surely you've made a table. Let's pick some important numbers. Negative 11. So I've got negative 11 minus the 10, and then I've got a negative 11 plus the 10, and I'm just plugging that into the original here. I have absolute value of negative 21 minus the absolute value of 1. And so I got 21 minus 1 is a 20. Positive 20. Okay. And I'm going to do this again for all these next numbers. So negative 5, I plug it in, I get a positive 10. And then I plug in 0, I got a 0. And then I plug in a positive 5, and I'm getting a negative 10 out of that. And finally a negative 11, and I get a negative 20 out of that. Okay, so I just did all the math really quick for you. What's going on is that I have negative x values, but I yield positive y values. So I'm like way up here, and then it does this, and then it does this. That's your graph, okay? You could do a lot more table than I did. Also notice that it's going to be a multiple choice, so you just pick the one that looks the best. The other options typically look like this. There's another one that might do, I'm trying to remember them all. They look something like this here, okay? One of these or one of those. You're picking the one that makes sense with the table that you made. Okay. Lastly, they're asking about, hey, when is this graph increasing? When is it decreasing? And where is it constant? From the graph that you chose. And so notice that we got constant, and then we got decreasing, then we got constant. So there's no increasing. You would just click none. Decreasing, I'm from right here. I believe that's going to be a negative 10 all the way over here to 10. So negative 10 to 10. And then constant is going to be everything else. So negative infinity all the way to the negative 10. I got a comma separated, and then 10 to infinity. So this portion and this portion. Again, the arrows are deceiving. You're not wanting to look at the arrows. You're just saying, look, I'm starting over here on the left side, negative infinity, all the way up to negative 10. And then from 10, I'm going off the page, positive infinity. Okay. So those are your answers there. And that's it. Whew. That's done with that section finally. If you have any questions, just let me know. Other than that, thank you very much. Have a great day.